Welcome back for another math tutorial from the Math Tutor For You channel. In today's video, we're going to be dealing with inequalities and their graphs. So if you find this video helpful, don't forget to smash that like button. Also feel free to subscribe to this channel to stay up to date with videos that are posted. And you're welcome to leave a comment down below with any topics from algebra that you would like to have covered in future videos. Alright, let's get to today's video. Inequalities. We're going to talk about solutions of an inequality. So what is a solution of an inequality? Well, here's our definition. A solution of an inequality is any number that makes the inequality true. So for example, let's say we have the inequality x is less than 3. So the solution to this inequality would be any number that is less than 3. So for example, 2, -1, or 0. However, if we have a number greater than 3, like 5, this would not be a solution of the inequality. So remember, our inequality signs are less than, greater than, less than or equal, or greater than or equal. Now, I want you to consider the following. Is each number a solution of this inequality? And the inequality is x is less than or equal to 7. So A, we have 9. Is 9 less than or equal to 7? So if we plug in 9 for x, we find that it's greater than 7. So the answer is no. 9 is not a solution of the inequality. How about B, where we have -1? If we plug in -1 for x, -1 is less than 7. So therefore, -1 is a solution of the inequality. Now for C, we see a fraction. That's okay. Fractions can still be solutions of an inequality. So 14/2. Well, this reduces to 7. 7, in fact, is equal to 7. So 14/2 is a solution of this inequality. So A and C would both be solutions, while B would not be a solution of the inequality. Now, something important to keep in mind. You can determine whether a value is a solution of an inequality by evaluating an expression. So, let's go through an example of this. We're going to have the inequality 2 minus 5x is greater than 13. And we're going to have two numbers, and we're going to figure out, are they solutions of the inequality? So the first number is going to be 3, and the second number is going to be -4. So by evaluate, it means we're going to plug these numbers in for x and see if the inequality is true. So starting with 3, we have 2 minus 5 times 3 is greater than 13. So we want to see if the left-hand side is greater than our right-hand side. So solving this, we have 2 minus 15, and we're saying, is that greater than 13? Solving for our left-hand side, we see it's -13, and that, in fact, is actually less than 13. So therefore, the inequality is not true. If the inequality is not true, then 3 is not a solution of the inequality. So let's try the exact same thing for -4. Plugging in -4 for x. We have 2 minus 5 times -4, and we're saying, is that greater than 13? We're going to solve our left-hand side. So we have 2 plus 20. If we solve that, we get 22. And we have to ask, is that greater than 13? Well, what do you think? Yes, it is. So therefore, the inequality is true. So -4 is a solution of the inequality. Now, in the first part of this video, we've talked about figuring out whether a number is a solution to an inequality. And we see, as we began this video, with x is less than 3. Any number that is less than 3 is a solution. So, inequalities can have more than one solution. Therefore, we can use graphs to indicate all the solutions. So we're going to go through some problems of how to show on a number line the solutions to an inequality. Let's start with this example. X is less than 3. So that means any number that's less than 3 is going to be a solution. So let's draw our number line. We're going to start with 0 in the middle. Going to the left, we're going to have -1, -2, -3. Moving to the right-hand side, we'll have 1, 2, 3, and 4. So we're saying less than 3. So we're not saying equal to 3. So on 3, we're going to put a circle, but we're not going to color it in. Why? Because 3 is not a solution of the inequality. If it was, we would color it in, but in this case, it's not. So we're going to leave just a circle for 3. And we're going to then draw a line with an arrow in the left direction, moving in the negative direction. And that's going to be our solution. We're showing that any number that comes before 3 is going to be a solution. But again, 3 is not a solution. So let's go through an example where our number in our inequality is a solution. We're going to have the following. H is greater than or equal to -2. So again, we're going to draw our number line. We're going to put 0 in the middle. Going to the left, we're going to have -1, -2, -3. And to the left, we're going to have 1, 2, and 3. So in this, we have H is greater than or equal. We see the equal sign there. So at -2, we're going to draw a circle and we're going to fill it in. Again, the filled in means that -2 is a solution. And again, we're looking for greater than. So we're going to draw a line with an arrow going in the positive direction. Any number that's greater than -2, showing those are our solutions to the inequality. So let's go through a few practice examples of what we've talked about. We've handled solutions of an inequality. We've talked about how to graph them. And now let's put all this into practice. Here's our first problem. Again, you can pause this video, try it out on your own, and then come back and watch the solution. Is each number a solution of the given inequality? And we have 4 minus m over m is greater than or equal to 5. And we're asked, is 2 and 0.5 solutions of the inequality? So we're going to use the first part that we talked about. We're going to evaluate to see if our inequality holds to be true. If it is true, then it is a solution of the inequality. So plugging these in, we're going to have 4 minus 2 divided by 2. So plugging in 2 for m and solving our left-hand side, we'll get 2 over 2, which is 1. And we have to ask, is this greater than or equal to 5? Well, the answer is no, you're correct. It is no. So therefore, is 2 a solution of the inequality? No. Moving on to 0.5. We're going to have 4 minus 0.5 divided by 0.5. Solving our left-hand side, we'll get 3.5 over 0.5. Doing our division, we'll get 7. 7 is indeed greater than 5, so 0.5 is a solution of the inequality. Next, we're going to go through a few challenging problems. We're going to define a variable for a situation and write our own inequality using everything that we've talked about. So here's our first one. A bus can seat at most 48 students. So for seats, we're going to call it S. That's going to stand for the number of seats. And we can have at most 48. So we can have exactly 48 seats or anything less, 45, 46, and so on. So to write our inequality, we'll have S can be less than or equal to 48. And that's what our answer would be. That simple. Let's go through another problem. In many states, you must be at least 16 years old to obtain a driver's license. So here in this problem, we're having age. Age can be equal to 16 or greater to have a driver's license. So pause the video, try to write an expression on your own. We're going to have A stand for age. So A can be greater than or equal to 16. All right, next problem. It is not safe to use a light bulb of more than 60 watts in this light fixture. So it's saying that we can't have a bulb that is greater than 60. However, it's still safe to use a bulb that is 60. So we're saying it's not safe. So we're going to have bulb. We're going to represent it with a B. So the bulb has to be less than or equal to 60. Hope you found today's video helpful, going over solutions of an inequality and their graphs. Again, if you found this helpful, don't forget to like, leave a comment down below, and I'll see you in the next video.